What is the hybridization of the indicated carbon atoms from left to right? So if we're looking for the hybridization of carbon atoms, we have three possibilities. So we can have a carbon that is sp3 hybridized, and we can recognize this as a carbon that is forming 4 sigma bonds and no pi bonds. Okay. The second possibility is we can have a carbon atom that is sp2 hybridized, which can be recognized as a carbon atom that is forming 3 sigma bonds and 1 pi bond. Or we could have a carbon atom that is sp hybridized, and this would have 2 sigma bonds and 2 pi bonds. And so we'd want to make sure we remember what bonds, how do we recognize sigma bonds and how do we recognize pi bonds? So sigma bonds are all of your single bonds. And if you have a multiple bond, the first connection is a sigma bond. And so we'll just say one of a multiple bond. And we'll see what we mean when we take a look at this molecule. And so your pi bonds, right? So whenever you have a multiple bond, and this kind of goes with the point we just made here about multiple bonds. So whenever you have a multiple bond, one is a sigma bond and the remaining are pi bonds. Okay, so that's how we can classify this. And I also want to take a look at this chart here. We drew this specific to carbon. We can also expand this to nitrogen and oxygen if we just consider the number of pi bonds. So if we count pi bonds and just pi bonds only, we can use this to relate back to the hybridization of carbon, nitrogen, and oxygen, which will be handy for us as organic chemists because we come across these elements all the time. All right, so if we take a look at this first carbon atom that we have indicated, we don't see any multiple bonds, so there are no pi bonds. It is a carbon with a full octet. We know that because we don't see a charge on it. So that means that we're dealing with something that's sp3 hybridized. So it has 4 sigma bonds. And so just in case we're still getting comfortable with these structures, we can see 1, 2, 3 bonds to that carbon. So we might be tempted to say, oh, there's only 3 sigma bonds. But what we need to remember is that if this is a neutral carbon atom, it has to have 4 bonds. And so what's understood to be here is a bond to hydrogen. And I put it in on this dashed line to represent the tetrahedral geometry that an sp3 hybridized carbon has. So we weren't asked about geometry, but I'm going to add this connection in, that if you're dealing with sp3 hybridization, you're dealing with something that is tetrahedral. And then if we move to the next carbon atom, we can see a multiple bond here. So we know about multiple bonds is that one of those bonds, the first connection between 2 atoms, is going to be a sigma bond. The remaining one would be a pi bond. So we have 1 pi bond and 1 sigma bond there, a single bond, so that is a sigma bond. And again, we have understood, kind of unfortunately in the same place we had that arrow, a bond to a hydrogen. So that would be the 3rd sigma bond. So we'd have 1, 2, 3 sigma bonds and that pi bond. So this is an sp2 hybridized carbon. And sp2 hybridization is related to trigonal, I'll try spelling this again, trigonal planar geometries. Those flat with 120-degree bond angles. Okay, and if we look at this last carbon atom, I'm actually going to take my arrow up here because we don't have a whole lot of space down here to look at. So we've got a carbon where we can see a sigma bond here. Here's a multiple bond, so one of those is sigma. So we have 1, 2 sigma bonds. The remaining 2 bonds are pi bonds. So we are looking at this sp hybridization. And sp, where you have those 2 electron groups, the farthest apart those can get is just to spread themselves out in a straight line. So this is associated with linear geometry. So to answer the actual question, though, we're really looking for the hybridization. So we know, going from left to right, we have sp3, sp2, sp, and that is option A.